In this video, we're going to talk about how to graph linear inequalities. So graphs of linear inequalities are different from the graphs of lines. That is because they have two parts. They have a boundary line and a shaded region. So you can see here in the graph of y is less than or equal to x plus 1, the blue line represents the boundary line. The shaded region in gray shows you all of the points that are solutions to the inequality. So the boundary line is the line that you have when you graph the inequality as though it were an equation. The boundary line will be dotted if your inequality has a less than sign or a greater than sign. The boundary line will be solid if your inequality has a less than or equal to sign or a greater than or equal to sign. So let's talk about what type of line you would use to graph these four different inequalities. If you have y is greater than or equal to 4x plus 1, the greater than or equal to means that you would use a solid line. If you have 3x minus 1 is greater than 5, the greater than sign tells you that you would use a dotted line. If you have 2x minus 5y is less than or equal to 12, the less than or equal to sign tells you that you would use a solid line. If you have y is less than 2x minus 4, the less than sign tells you that you would use a dotted line. So once you've graphed the solid or the dotted line, you're going to shade the region depending on the inequality sign. So what you're going to do is plug in a test point that is not on the line. 0, 0, which is the origin, is usually a good choice. If the point makes the inequality true, you're going to shade the region that includes that point. If the point makes the inequality false, you're going to shade the region that does not include the point. So for example, you can see here the point 0, 0 is included in the shaded region. If I plug into this inequality, I get 0 is less than 2 times 0 plus 1. So that is saying that 0 is less than 0 plus 1, which tells me that 0 is less than 1. That is true, so that is why the region that includes 0, 0 is shaded in this graph. So just a quick warning for those of you who like to use Desmos, the testing version of Desmos that you'll be given on the STAR test will not allow you to graph inequalities. So let's practice graphing. Let's graph the inequality y is greater than x plus 4. So to start off, we're going to graph y is greater than x plus 4 as though it were a line. So let's think about y equals mx plus b, because that is how we figure out what we need to graph. So in this case, m, which is the number in front of x, is going to be 1. Because remember, if I have no number written there, that is an implied 1. So the value of m is 1. The value of b is 4. That means I have a y-intercept at 0, 4. So I'm going to go there and plot my first point. Now I have slope, which is m, equals 1. Remember, I can write this as a fraction. This will be 1 over 1, which means that I go up 1, right 1, in order to plot my second point. So my second point will be here when I go up 1, right 1. And then now I need to figure out whether I need a dotted or a solid line. I have a greater than sign, so that means I will use a dotted line to connect these 2 points. So now that I have my line, I need to figure out which direction to shade. So I'm going to use the test point 0, 0 because that is not included on my line. So I'm going to plug into this original inequality and I get 0 is greater than 0 plus 4. So this is telling me that 0 is greater than 0 plus 4, which is 4. So this is false because 0 is not bigger than 4. So I'm going to shade away from 0, 0. So I'm going to be shading the part of this graph that does not include 0, 0. So now let's graph the inequality y is greater than or equal to 3/4 x minus 2. So I have y is greater than or equal to 3/4 x minus 2. Let's think about y equals mx plus b. So in this case, the value of m is 3 over 4. The value of b is negative 2. That means I have a y-intercept at 0, negative 2. So I'm going to plot that first point. And now let's think about m, which equals 3 over 4. So 3 over 4 means I'm going to count up 3 and right 4. So from this point, I'm going to go up 1, 2, 3, and right 1, 2, 3, 4. So I plot my second point here. I need to figure out whether I need a dotted line or a solid line. So this inequality sign tells me that I need a solid line to connect these 2 points. So I'm going to connect my points. And here's the graph of my boundary line. So now I'm going to use a test point. I can once again use the test point 0, 0 because that is not on my line. And I can plug into this inequality. So that tells me 0 is greater than or equal to 3 over 4 times 0 minus 2. So this is saying 0 is greater than or equal to 3 over 4 times 0 is 0. So 0 minus 2. So I have 0 is greater than or equal to negative 2. That is true. So I'm going to shade the side of my graph that does include 0, 0. So that is this part of the graph right here. And I'm just going to shade all of that in. So now let's graph 3x plus 4y is greater than or equal to 8. So if we think about this, and then we think about slope-intercept form, well, this is not in slope-intercept form. So I need to do some rearranging to get my inequality into slope-intercept form. Remember that in slope-intercept form, my y is basically by itself. So I'm going to do opposite operations until I get y by itself in this inequality. So I'm going to start off by subtracting 3 from both sides. So I can subtract 3x because I have 3x, which is a positive 3x. So I can subtract 3x from both sides. So when I do that, on the left side, this cancels, and I have 4y is greater than or equal to negative 3x plus 8. Now to get y by itself, I'm going to divide everything in my inequality by 4. So when I divide by 4, I have y is greater than or equal to negative 3 over 4 x plus 8 over 4, which is 2. So now you can see this is in slope-intercept form. So negative 3 over 4 is my value of m. 2 is the value of b. So that means I have a y-intercept at 0, 2. So I'm going to go there and plot my first point. And then I have a slope, m equals negative 3 over 4. Negative 3 over 4 means that I go down 3, right 4. So I'm going to plot my points down 1, 2, 3, right 1, 2, 3, 4. So here's my second point. Now I'm going to think about dotted or solid. Based on this inequality sign, I know that I need a solid line to connect these 2 points. So I'm going to draw in that line. And so now I need to use a test point to figure out which direction to shade. So if I think about this, I can actually use the point 0, 0 because it is not on my line. So I'm going to plug into my original inequality. So I get 3 times 0 plus 4 times 0 is greater than or equal to 8. 3 times 0 is 0 plus 4 times 0 is 0. And this is saying that's greater than or equal to 8. Well, this tells me that 0 is greater than or equal to 8. That is false. So I'm going to shade the side that does not include 0, 0. So that would be this part of my graph that is on the other side of 0, 0. Now let's graph x minus 2y is less than 6. So once again, x minus 2y is less than 6 is not in slope-intercept form. So I'm going to have to rearrange my inequality. So I'm going to start off, this is a positive x, so I'm going to subtract x from both sides. So this leaves me with negative 2y is less than negative x plus 6. Now I need to divide everything by negative 2. And when I do that, on the left, I have y. Since I divided by a negative, I need to flip the inequality sign. Here I have negative x over negative 2. Remember that negative x is basically negative 1x. So negative 1 over negative 2, remember that a negative over a negative is positive. So that is going to be 1/2 x. And then I have plus 6 over negative 2. So that is going to end up being negative 3. So I have 1/2 x minus 3. 1/2 is my value of m. minus 3 is the value of b. So I have a y-intercept at 0, negative 3. So I'm going to plot my first point there. And then I have a slope, m equals 1/2. So m equals 1/2 tells me that I'm going to go up 1 and then right 2. So I count now up 1 and then right 1, 2. So that is my second point. Since I have a less than sign, I need a dotted line to connect these 2 points. And I'm going to once again use the test point 0, 0. Since it's not on my line, I can use 0, 0. I'm going to plug into this original inequality. I get 0 minus 2 times 0 is less than 6. So this is 0 minus 2 times 0, which is 0. 0 is less than 6. 0 minus 0 is 0, so 0 is less than 6. That is true. So I'm going to shade this part of the graph that does include 0, 0, because that makes my inequality true. So now let's graph y is less than negative 2. So you can remember that this is one of those special lines, but if you don't remember, you can once again compare it to y equals mx plus b form. So remember, if I'm thinking about mx plus b, this is basically like y is less than 0x, right? Because there's no x term, minus 2. So 0 is the value of m, negative 2 is the value of b. So my y-intercept is going to be at 0, negative 2. So I'm going to plot that first point. And then my slope is going to be up 0 over 1, right? Because 0 equals m is like 0 over 1. So I go up 0, right 1. So if you remember, this is going to be one of those special lines that just goes straight across through negative 2. So once again, I need to think about dotted or solid. It's a less than, so it's going to be a dotted line through negative 2. So now I need to think about which direction to shade. I can use the test point 0, 0. And so when I plug in 0, 0, remember it says x is 0, y is 0. I only have a y in this inequality, so that's fine. I'm just going to plug in, and I get 0 is less than negative 2. So 0 is less than negative 2 is false, because 0 is actually bigger than negative 2. So I'm going to shade this entire bottom region that does not include 0, 0.